let's understand how do we derive time period for simple pendulum. Now assume this to be a simple pendulum which has string of length L and bob of mass M and is swinging this way, okay, and for any displacement x it has covered angle theta, okay, and this is the tension acting towards the support. We always know that whenever tension is there, it's always towards the support wherever it is supported. All right, so similarly here also, so identically here also tension is directed towards the support. Now we know this is the direction of mg. Now since this is the direction of mg and this is tension, so we have got to find which is the component which is balancing tension. All right, so what do? Is we resolve mg into mg cos theta and mg sin theta. We know the rule of resolution that whichever is adjacent to theta gets cos and away from theta gets sine. So identically here also it is mg cos theta and this is mg sin theta. All right, and why is this theta? These are two parallel lines and this is transversal. This makes angle theta over here, so this also has to be angle theta as per corresponding angle theory. All right, okay, so this is theta, so this becomes mg cos theta, this becomes mg sin theta. What is mg cos theta doing? Mg cos theta is balancing the tension part of string. And what is mg sin theta doing? Mg sin theta is the restoring force provided to bob to go back. All right, so the equation is set. So we know force, restoring force is mg sin theta. So coming back here now, F is minus mg sin theta. Now whenever theta is less than 10, we can approximately take sin theta is equal to theta. Why so? I'll explain it very shortly. I would be explaining it. All right, okay, so F is approximately equal to minus mg theta. Now I didn't explain you why minus because restoring force is directed this way whereas displacement is directed this way, so both in opposite direction, so it is minus. All right, okay, so let's proceed ahead. Now instead of theta we are finding here x over L. Why so? This is the part which I have reproduced over here. Now we know this is angle theta, this is angle theta, and we know this is 90 degree, this is 90 degree, so this is hypotenuse, right? Now we know sin theta is opposite over hypotenuse, so that's the reason why sin theta is x over L. Now it is theta, so theta is x over L, and that's what we substitute. Now mgl are constants, so F is directly proportional to minus x. Now we say F is directly proportional to minus x, so the conditions for SHM satisfied. What do I mean by that? First condition is restoring force should be directly proportional to displacement. Theta is more, x is more, so restoring force also would be more. Restoring force is by mg sin theta. We know sin theta is directly proportional to theta. If theta value increases, like for example, if theta is 0, sin 0 is 0. If theta is 90, sin 90 is 1, maximum value. So sin theta is directly proportional to theta. So if sin theta is directly proportional to theta, then the restoring force also would be more proportionality to theta, and theta if more, then x also is more. So first thing proved. And yes, both are oppositely directed. Restoring force is in this direction whereas displacement is in this direction. All right, so satisfied, so we can assign it to be SHM. So this oscillation of pendulum can be assigned as SHM. Okay, let's move further. F is equal to minus mg x over L is equal to ma. We are picking it from here, this which we had derived. F is equal to minus mg xl. Now we begin it from, so we continue it from there. All right, so F is equal to minus mg x over L. Now we know F is equal to ma, so mm gets cancelled. So acceleration is equal to minus g x over L. or we can take x down there below, so it becomes a over x, which is equal to minus g over L. We know g is gravitational acceleration due to gravity, g. All right, and in case we want mod, then negative sign disappears, so it is g over L. Now a over x is acceleration per unit displacement. All right, now we know formula for t is 2 pi over omega, and we also call it as, which I have derived already, acceleration per unit displacement. Instead of omega, we also can write it as acceleration per unit displacement. All right, so t becomes 2 pi root of L over g. All right, 2 pi root of L over g. Why L over g? We already have derived that a is equal to g over L. So we put g over L over here in the denominator. Now when we do that, what happens is t turns out to be 2 pi root of L over g. Alright, well, L is length of string of the pendulum, and so and g is acceleration due to gravity. Pi we know is a constant, 3.142. Alright, and if we go in terms of frequency, it is, we know, reciprocal of time period, so n is equal to 1 over t, so entire thing gets in reciprocal form, so 1 over 2 pi root of g over L. Now this is the formula which we have got to keep in mind. Both the formulae we have got to keep in mind for our numerical purpose. This also is yet another very important formula for our numerical purpose. Now time period is equal to 2 pi over root of acceleration per unit displacement. I've seen number of numericals appearing in competitive exams concerning this formula. Okay, then so let's conclude this. So what's the conclusion? Conclusion is t is directly proportional to length of pendulum, t is inversely proportional to acceleration due to gravity, and t is independent of mass. We don't see anywhere, we don't see mass into picture, so whether the bob is heavy or light doesn't make any difference, and t is independent of amplitude. Now keep one thing in mind, there are lots of questions being asked about gain in time and loss in time owing to increase or decrease in length of pendulum, or moving into planet with a pendulum where gravity is less.